Going on to topic 5 now of chapter 3. This is the last section we're going to do in chapter 3. And what it deals with is equations of the lines that we've been working with. And our first objective will be to graph a line using its slope and y-intercept. And then use the slope and the intercept form to write an equation of a line. And then we're going to use an equation we didn't use that much yet, which is equation 4, which is called the point slope form. And then we'll write equations, this would be formula 5 and formula 6 of a horizontal line and a vertical line. And then we're going to be able to take a look at an equation and then write another equation that is parallel or perpendicular to the line already given. Okay, so we're going to jump right into this. We're going to graph this using its slope and its y-intercept. Now, we know this equation is in the form y equals mx plus b. Now, b is the y-intercept, so we see the y-intercept is a -3. So in this technique, we put a dot on -3. Now we look at the slope, which is the coefficient of our x term, when we solve it for y, and we see it's 1/4. Now we know slope is a ratio of rise over run, spell that right, and it's y units over x units, and it's positive. Now there's different ways to do this, but I would suggest plot the run first. If the run is positive, from this y-intercept you're going to go over 4 units. 1, 2, 3, 4, which will bring you right over here. You do this mentally. You've clicked on this dot, you go over 4, and now you're going to go up 1 unit for the rise. And you take your line tool, and that is the graph. And you see it right over here. -3 over 4 up 1. And you've plotted that. And you might say, up to now you've been doing T-charts, getting various points. This is a shortcut. Now in example 2, they're asking you to do this one, which is 2x plus 3y equals 12. Now this is in standard form. Well, you could solve for y and do what we've just done, but I'm suggesting when it's in standard form, you use that special T-chart, x and y, and then a 0 and a 0, and find your intercepts. So this would be, if x is 0 here, y is going to be 4. Now if x is 0, y is 0 here, x is going to be 6. So when you would graph this, once again, 0, 4, 1, 2, 3, 4, a dot there, and 1, 2, 3, 4, 5, 6, a dot there, and you're using your intercepts. And your line would go like so. Now, just to do what they're asking, and again, it's nice to have an alternative, And if we solve this equation for y, we transpose the 2x. On this side's a negative 2x. Now we divide everything by 3. And we get our slope now is 2/3 x. And our y-intercept is 4. So let's do that. Plot our y-intercept, which is right there. Now our slope is a negative 2/3. So we're going to go over 1, 2, 3 units this way, and then up 2, and we get the same line. Now we could have gone down 2 over 3 and to this point there. Now, using this method, you don't usually find the x-intercept. But I'm suggesting if it's in standard form, this x and y intercept t-chart is a good way to go, especially if their numbers are even like this. So here in the textbook is the graph. Our y-intercept is 4. Could have gone over 3, up 2. 1, 2, 3, up 2. Or go down 2 over 3. All right? There are more ways. Remember, there's an infinite number of points, and what you're doing is making these little triangles with a ratio of rise over run, y units over x units. Okay, let's go on. For example 3, they're asking us to write an equation now in slope-intercept using the slope and the y-intercept. So for this, you're going to have the general formula y equals mx plus b. So you take your y. Now the slope is 1/4, so you put that where the m is. Now you need to include the x, and then now your y-intercept, we just put the y value, which is -3. And there's our equation. And for this one, it would be y equals, again, the slope is -3/4. Need to put in the x, and your y-intercept is 4. Some easy stuff. Now, in checking out this concept check, here they had the y-intercept of 0, 4 and the slope of 2. And what do? They put them in the wrong place. The 2 should go in front of the x, and the 4 is your y-intercept. Now, in closure of chapter 3, we finally get to use this formula that we are calling the point slope form, formula 4, in which you have the slope and 1 point. Now, in some cases, if we didn't have the slope, but we had 2 ordered pairs, we could then find the slope using the slope formula, and then take the slope, put it in this form, and use one of the points. And this formula, by the way, is derived from the slope formula. Now, in example 4, they're giving us the slope, and they want the line to go through this point. So we use the point slope formula. And you might say, you'll never be able to memorize this. Well, on this side it's 2 y's and it's subtracting. This side is 2 x's and you're subtracting. And you put an m in front of the 2 x's here. So let's substitute. So we get y minus, now our y value is negative 5. So since there's a negative in the formula, we're going to have the opposite here of a negative 5. We'll make this a positive 5. And now we put in our slope, and then x minus is in the formula 1. So that wasn't too hard. Now we solve again for y. After clearing, y plus 5 equals a negative 3x plus 1. Now we're going to take our positive 5, transpose it. On this side it becomes a negative 5. So we have y equals a negative 3x minus 4. Well, almost, and I need to copy this right. I got that part. There's a 1 there. Now, negative 3 times negative 1 is a positive 3. That's better. So now when I subtract 5 from both sides, this becomes a negative 2. And you need to check your work, as I have to do. Apologize for that. Now, in this case, we have 2 points, and we don't have the slope. So we would have to use formula 3 to find out what the slope is. So the slope is 5/8. So we can put the 5/8 right there. And then x, and then y, and we have to put in the one of the pairs. Now they're using this pair, so let us use this one. And by the way, notice this is an x-intercept, so that doesn't help us that much. So let's use the negative 5 for the y, so this will become a positive 5. And this is a negative 4, so this will become a positive 4. Remember, the opposite of a negative makes it a positive. Now, one of the things I think is useful here is something from chapter 2 when we have a fraction like this. So we don't have to work with fractions. Let's multiply everything by the lowest common denominator. And again, each term by the lowest common denominator. This is all one term. So this cancels out here. And now we get 8y plus 40 equals, now we'll distribute, 5x plus 20. So we then get 8y, and we're going to take our 40, transpose it to this side as a negative 40. So this equals 5x minus, now we're subtracting 40 from both sides, minus 20. And notice this is what they have here as well, even though they used another ordered pair. Now we divide both sides by 8, and we get y equals 5/8 x minus 20 over 8. Now this can be simplified by taking a 4 out of each one, and this part will become a negative 5/2. And basically that's what they're going to get. And this is in slope-intercept. So let's just take this part off, because this is what we simplified it to. And we see how they worked it out on the next page. Okay, in example 6, and I had mentioned that we could do this earlier, we can actually look at a graph and figure out what its slope is, and then using any one point, find the equation of that line. So let's figure out what they've done here. And we had said you could also just pick the slope out from the graph. So how many units did we go over for our, remember it's y over x. We went over 1, 2, 3, 4. So we're going over 4 points. And how many are we going up now? 1, 2, 3. So our slope, and you could have used the slope formula using these 2 points, but since we had the graph, we're just counting it. So this is 3 over 4, and it's positive. Now we then put in one of the points into formula 4, and I would multiply everything by 4, which is what they're doing here, and then eventually get our formula. And there it is down below. Now this one happens to be in standard form. And notice the Y-intercept over here is not on a grid point. And neither would it be here. So that one would be kind of challenging. If we were on the grid point, we could pick out our Y-intercept right away. All right, let's go on. And example 7, where we use data to predicting sales. Let's take a look at our next page. So this real estate agency has been in business for a while, and starting in the year 2000, so in 2002 they sold 200 houses, and then in the year 2007 they sold 275 houses. So by plotting these 2 points, we get this graph, and by using these 2 points of data, we can actually figure out a slope. And the slope of this turns out to be 15. Then, taking this as the slope and using, in this case, this set of data for our single point, we are able to put it in point slope form and come up with an equation for this particular line. Now, assuming that this is the average of sales, you might predict for year 2009, 2011, if all remains the same. But I don't know if you recall, in 2008 there was a big dip in the housing. But for our mathematical purposes, this is an example that we could have worked. So you get 2 points of data, put it in the slope formula. Once you find the slope, take one of the points, put it in point slope form, grind it out. That gives you the equation then for that line. And then if they're saying 2016, which is what it looks like here, You then multiply 16 times the 15, which is your slope, get a product here, add it to 170, and you could predict that in 2016 you would possibly sell 410 homes. Okay. Objective 4 is writing equations for vertical and horizontal lines. Now, this should be easy if we remember a couple of things about these. And let me review. Well, for a horizontal line, we said that was formula 5, and that's y equals b. So if you had an ordered pair, A, comma B, and they wanted a horizontal line, and that would be a line with 0 slope or a horizontal line, you would just take your B item of an ordered pair, and that would be your equation. So here they're giving you a point. They're saying they want to write a horizontal line going through this point. Then your B value, which is your y coordinate there, the B value, that would be your equation. Y equals 3. And there it is. Now, for example 9, they want you to find an equation for a vertical line. That is, x equals a. Now, they would have to define this as a vertical line or a line of undefined slope. So, again, in an ordered pair, if it's a vertical line or an undefined slope, it will be whatever is in the A or the X position, and that would be your equation, x equals A. So here, in our ordered pair, the element we're going to choose is our X item, which is in the A position, and that would be x equals 2. Again, they're saying one with undefined slope is going to be x equals 6. In Objective 5, we're asked to find equations of lines that are parallel or perpendicular to an equation they give you. And they'll also tell you what form they want the answer in. So let's take a look at number 10. Find an equation of a line containing this point and is parallel to this line. Well, if it's parallel to this line, it must have the same slope. So what they're showing here is solving it for y, putting it in slope-intercept form, and thus finding out what our slope is. And then taking this slope, but using this point in the point slope form. So let's do that. So y minus 4 equals the slope of a line parallel to this, a negative 2/3 times x minus, now our x element, 4. So we found the slope, but then we're using the point of the new line that we want this line to go through. So again, I would suggest you multiply everything by the lowest common denominator to get rid of the fractions, each term. This is one term, all of one term. So we multiply each term by 3, and here the 3's cancel out. So now we get 3y minus 12 equals a negative 2 times x, a negative 2x. A negative 2 times a negative 4 is a positive 8. So we then get 3y equals, we're going to transpose this on this side, a negative 2x. This becomes a positive 12, so plus 20. Now they want the answer in the form y equals mx plus b. That is slope-intercept. So we just have to solve for y now by dividing everything by 3. And we get y equals a negative 2/3 x plus 20/3. Now notice it has our new slope, or the slope, and it's going through these points right here. And where I had that in slope-intercept form, if I would have read the text a little more carefully, they wanted it in standard form. Now remember, in standard form, we put the x and y on the left side of the equation with our constant over here. And we'll do the next one like that. Let's read this one carefully. Well, this one they actually want in slope-intercept. Okay. But we're using that very same equation. We want a line now that is perpendicular to this and going through that same point, 4, 4. So the first thing we have to do is find out what is the slope of this line. Well, you may recall that the slope of this line was a negative 2/3. Well, if this is the slope of this line, it's going to be parallel to it. What would the slope of a line perpendicular to this slope be? Well, it's negative reciprocal, or opposite sign reciprocal. Remember, we want to get a -1, so that would be 3/2 would give us a -1. So our new slope of this line is going to be 3/2. So let's put that in the point slope form. Y minus 4 equals 3/2 now times x minus 4. So once again, we want to get rid of the fractions by multiplying this time everything by 2. So here the 2's cancel out, and we get 2y minus 8 equals 3x minus 12. And we bring our -8 over, and we get 2y equals 3x. Now this -8 on this side becomes a +8, so this is going to be minus 4. And now we divide everything by 2, and we would get it in slope-intercept. And that's what this one would be. But let's say we wanted to get this one now in standard form. Here we're just solving for y to get it in slope-intercept form. But to put it in standard form, we take our x term from this side, move it to this side, and we get a negative 3x plus 2y equals a -4. Now this is standard form, but usually they don't want this first term to be negative. If we don't want this first term to be negative, what do we have to do to each term so that we change all of the signs. And that is, we multiply each term by a -1. So this would then become 3x. This would become a -2y. And this would become a +4. So this is the form in MATLAB they usually want. Now if you had put this in and they marked it wrong, I would give you credit for it. I'm able to override the system. Okay, we've done a lot of work on equations, and there is a summary similar to what we've given you already, except we like to have this one read y equals b, and this one x equals a. We call this Formula 1, Formula 2, Formula 4, Formula 5 as reference, and Formula 6. Now the one they're missing is Formula 3, which is the slope formula. Now some have suggested that you put these formulas on little index cards and this little flashcards to help you remember them. These are going to be important formulas as you see throughout Chapter 3. And in your online textbook, again where I'm getting this from, they give you a number of little problems to work, but you have your practice quiz me, and we're getting ready for our test.